Hi everyone, welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today I have my special guest Rob. Rob, welcome to the podcast. Would you like to introduce yourself?
Yeah, thanks for having me, Tom. Rob Tiffany. I've been doing IoT for way too long. Helped design Azure IoT, building that around the world. Got to do industrial IoT, digital twins at Hitachi, living in Japanese factories. Spent the last several years at Ericsson doing 5G and IoT connection management for global SIMs. And now I'm off doing crazy stuff like writing code and writing a book. So who knew?
Nice. And I gotta say, welcome to the very first video episode of the Climate Confident Podcast, because you're aware, but people who are listening to this on audio might not realize that this is being recorded in audio and video, and I'll be publishing it on YouTube as well as on the normal podcast channel. So congrats on being number one.
We're number one. Awesome. Yes. What a pleasure. I'm honored. Not that anybody wants to see my face, but
I've got a great face for radio. Yeah, this is why I stayed audio only for so long.
Right there with you, man. Absolutely.
So tell me, Rob, you have a long background in IoT, as you mentioned, and you and I go way back in terms of IoT as well. But what's IoT got to do with climate?
Well, it turns out if we kind of we get away from all the esoteric aspects of IoT and all this AI talk and everything. If you break it down, what is it really? It's just measuring something. You're using sensors to measure something in the environment, something in the real world. You know, IoT is an API for the real world. And so, and it lets you do things remotely and in real time. And so, as it turns out, there's that quote, Peter Drucker, basically, if you want to manage or improve something, you've got to measure it, right? Otherwise, You can't improve it. And so it starts with measuring. And so IoT is a replacement for millions of people running around all over the place, going in person to take measurements or readings or to see what's going on with emissions or whatever. And so in this world where we've got this great technology, these sensors, these devices, we've got wireless networks, we've got these IoT platforms and technologies. We've got all the tools we need to continuously monitor the world around us, and it's, in my mind, it's not always about things like predictive anything. It's just, hey, we just need early warning, like a smoke detector in your house. It doesn't have to be rocket science. I got involved with IoT and sustainability. It was when I was at Ericsson. I found myself on a panel discussion that we were doing in our office in Santa Clara like 5 or so years ago, where I was on a panel with the heads of sustainability for all these giant companies like AT&T and others. And I'm there on behalf of Ericsson, and I'm supposed to talk about how IoT can help sustainability. So I had to do my homework and to get my act together to be ready to try to sound intelligent on this live broadcast we did. But you know what? It was probably one of the most important things I did, because then I realized, hey, this IoT stuff can be used for things beyond business and commercial. It turns out it can make a big impact on society across the board. And so ever since then, it's kind of snowballed, and I find myself writing about it, speaking at conferences about it more and more. And I'm passionate about the climate and sustainability across all kinds of areas. And so, it's like that Venn diagram. When something you're passionate about intersects with something you know something about, maybe some magic can happen. So that's kind of where my head's at.
Cool. And ultimately landed you on this podcast today.
Yes. Who knew?
The pinnacle.
Yeah. It is. I've reached the mountaintop. Yeah. Outstanding.
So tell me, you've built this platform. Talk to us about that. So first of all, why? What's the platform about that you've built? Why did you do it? And what's it doing?
Yeah. So I was an architect at Microsoft, and so I was kind of one of the co-designers of the reference architecture for Azure IoT, and got to build that thing. Then I got to build another one, an industrial IoT digital twin platform at Hitachi called Lumada, and both those things are in the leaders quadrant for Gartner. And so I was like, I know how to do this. I know how to
Mm.
build this stuff. And now I know the uses of it. But I also know that a lot of people in need can't afford a lot of those big platforms. They're just too expensive, And so I was like, what if I went the other direction? Instead of building some giant global thing in hyperscale clouds, what if I built a small thing that's lightweight, that's portable, that I could give away to nonprofits or to NGOs, government agencies, things like that, to go make a difference in the world. And so I basically built kind of what you would think of as maybe a stripped down IoT-ish platform, and I call it Greenhouse, and it's totally focused on sustainability. At a high level, all these platforms have a lot in common. They're basically middleware. You've got SDKs, software development kits for devices out on the endpoints that helps you pull together sensor information, package it up, secure, send it over the air to some platform. You catch it, you authenticate it, drop it in a message queue, pull that data out, do something with it. Maybe you're hydrating a digital twin. Maybe you're running it through some kind of analytics. And so I built all that stuff. Also, another thing I learned, which is great because I don't have the skill set to build some insane analytics package. That's way big. But you know what? It turns out when you look at the use cases to really move the needle and make a difference in a lot of societal issues, those things don't require neural networks or AI or anything complicated. It turns out the most important things in the world to solve actually use the simplest analytics. Sometimes I have trouble even thinking of this analytics. If you think about factory automation over the years, so much stuff is based on kind of what thresholds. Is it too hot? Is it exceeded this? Is it, whatever? Is it too cold? Is it RPM too fast? Whatever, things like that. Looking at gauges. It turns out a lot of things in this world are just that simple. And with the simplest low-hanging fruit, you can really improve things. In business, people are trying to use IoT to reduce costs, to find new business models, maybe to make new money, better customer service, safety, things like that. And so, anyway, you can apply that. So I built this platform. It runs anywhere. It's like portable, lightweight. You could run it in one of the hyperscale clouds if you want. You could run it in a data center. You could run it on VMware. You can run it on a little Intel NUC if you want, and deploy it. In my head, sustainability also goes to the technology you built to help drive sustainability. Is your platform using more CPU and I/O and all that stuff? I know all the Kubernetes people are going to kill me right now, but the more layers you put around code, but that you separate the code from the bare metal of the computer, the less sustainable it is, as it turns out.
Sure,
And
of course.
so, I saw that firsthand when I was at Hitachi. We built Lumada, and an early version of it was. This is so geeky. I apologize to your audience. It was the early days of microservices. That was really hot, and using Docker and trying to Kubernetes was early. There was other ones like Swarm and some others that we looked at, and we used Java. And turns out Java, back then at least, running in these containers and doing all this right stuff for architecture, ended up just ballooning how many resources you were using on the server.
Wow.
And I remember talking to the developers building the server code. I was like, I need you to think like an embedded developer. I need you to think like you're in sales when you're writing code. And they looked at me like I was crazy. But I was like, there's a cost to all this, these decisions you're making architecturally. And the cost was having to use like a larger size VM in AWS, for instance, than maybe what you really needed just because of architectural decisions. And so that kind of stuck with me. And so there's sustainability at every layer. Are your devices running a battery and using solar? Does your server, can that run on a low-end piece of hardware to not use a lot of electricity? That's kind of where my head's at with all that stuff.
Okay. And these NGOs and governmental organizations that you're talking about, what would they be using this for?
Well, that's why in concurrently writing all this code, I wrote this book. It's not out yet. I've been working on it. It's called, the title's going to sound like link bait. I apologize. But the working title is Saving the Earth with the Internet of Things. So back to kind of what I was getting into with speaking and writing and all this stuff. Maybe some of your audience is familiar with the United Nations 17 Sustainable Development Goals. You know what was really helpful for me with that is help categorize things for me. Sometimes you're wandering around in the desert and you're trying to do some good stuff, but maybe you need a little bit of direction. And so it was great to go, oh, okay, here's categories: poverty, hunger, climate, water, all these kind of things. And then you can start going, okay, what are the use cases around IoT monitoring and taking an action that fit in these different categories? And so that was super helpful for me. And so now, to answer your question, for each one of those sustainable development goals, I've got lists of use cases that are very prescriptive, actually. I didn't want to, this book is almost going to be like a handbook you give to somebody to go do something with, right? And so I didn't want to write a high-level thought piece on saving the planet. I wanted it to be very concrete and very prescriptive. Basically, it's like, okay, let's just take water, for instance, and agriculture. A lot of people don't know agriculture uses about 70% of the fresh water on the earth. And a lot of people don't realize everybody's like, wow, 70 whatever percent of the earth is covered in water. But there's only 1% of the water is fresh water.
That's right.
And then agriculture uses an outsized amount of that. Okay. Who would have thought agriculture is competing with humans and I guess animals and everybody else for fresh water? And so, boy, if you're out here, if you look in California, obviously they've gotten a lot of good rain recently, but they've been in an incredible drought. There's about 40 million people that depend on this Colorado River that's starting to dry up.
Yep.
And so there's this notion of being precise. Some people may have heard the term precision agriculture. Mm-hmm. How do you get to be precise in how much you use of a natural resource? Well, IoT is a great way to do it because it's measuring for you. And so a quick example could be under a chapter under, hunger or water, I guess, putting those sensors out on farms that's measuring soil moisture in the ground, temperature, humidity kind of thing. How are things evaporating? You can measure nutrients in the soil. And what you want to do is let the data tell you what to do. Obviously, people have been farming for thousands of years, and sometimes there's a lot of tribal knowledge. Grandpa told me that this is how you're supposed to do it on the farm. But there's a lot of younger people who maybe don't know that, and they're open to saying, let the data tell me what to do. And so you can imagine, like with this technology I've built, because it's all about trying to do automation and conserving. And so having those soil moistures, maybe one of these sensors per acre on your big farm, and then have it integrated with maybe either you've got a automated irrigation system, sprinklers, or someone may still have to go turn a valve to turn it on. But let the sensors tell you exactly, based on soil type and the crop, tell you when it's time to irrigate. And then just as importantly, I just keep it simple, like KPIs, key performance indicators. Instead of complex analytics, I do stuff that people understand. Most people, when they drive a car or something, they've probably seen a gauge where it's green, yellow, and red. Those kind of gauges in our lives all over the place. So it's like, if you're in the green zone, you're good. Yellow, you're kind of getting into a cautionary. You're moving in the wrong direction. And of course, red, we know, it's bad, it's danger, it's warning. So having a system, based on KPIs to keep it simple. An IoT platform could just be something that's doing pattern matching. I know I've set up a KPI for irrigation for this type of crop, and it says when it's between this percentage and that percentage of moisture in the soil, you need to irrigate in order to get back to the green zone. One of the things we all talked about early on with IoT was everything being connected and autonomous, and it was going to make decisions, and it'd be actually this invisible thing that's working behind the scenes for us at business and smart cities and all that stuff. What we've really delivered to the world is a bunch of dashboards and having people looking at screens and try to discern an insight. What I've tried to do is make an invisible system where it just makes decisions on its own. And so in this case, it knows exactly when to turn on irrigation, and then just as importantly, quickly turn it off because you don't have a lot of water to go around. You can imagine applying that to all kinds of use cases related to the consumption of natural resources, right?
Yep.
Because sometimes people are wasteful or they don't know any better, right?
Sure.
Okay, maybe a lot of time.
To go back to that water example, Rob, can you take in information from the environment as well, as in, sure, you're taking the soil moisture readings and you know that it's outside a particular parameter, so you then decide to switch on the irrigation, but what if it's going to rain in half an hour?
Yes, that's critically important. It's good to have data blending from other sources, not just your own system. And so, yes, you're going to suck data in from a weather service because that needs to be a reference, which is a great point you kind of bring up there. If we think about so many of these big IoT platforms that have been built, my takeaway a lot of times is they're just the same old siloed closed loop systems that people have been building for decades. They're just using new technology because it's vitally important, to your point, to pull in outside information and make decisions on a whole set of information. And you're trying to do this in real time. I'm not as much into the whole batch data, analyzing data sets to do machine learning, and more about kind of the real-time streaming type stuff and making decisions on the fly to automate a process. And so you're absolutely right. You should be pulling in weather data because you're right. If it's about to rain, then don't waste your time turning on irrigation. I just found in farming that turns out it was really valuable to monitor these microclimates around different areas, or there's these crazy, NPK sensors that you put in the soil that, because what's another natural resource we've heard in the news that we don't think about every day? As soon as we started having this war in Ukraine, there was some news just under the covers that says we might be having a shortage of fertilizer around the world because a lot of it comes from that. A lot of people don't know. There was what's the deal? It's some other name at Bosch that came up with this process maybe 100 years ago.
Haber and Bosch.
Haber. Yep. Yeah. This was a critical thing that no one's ever heard of that allows us to create artificial fertilizer. Nitrogen is your big thing, and ammonia and all that kind of stuff. As it turns out, a lot of people also don't, if it wasn't for that process, we actually couldn't support the population we have today. We wouldn't have been able to make enough food for what we have today. And so fertilizer is kind of a thing, but we can't waste it. And and also to make this artificial fertilizer, which is what most people use, very energy intensive to make it. The tremendous amount of fossil fuels are used in the production of this. And so anyway, it's always good to be judicious and try to use less of things in nature if you can. And so if you can put these sensors that are measuring nitrogen and things like that to be really precise, it says, hey, the soil in this section of the farm is good. We don't need to fertilize, just again, back to being precise about your usage of natural resources.
Yeah. So apart from water and fertilizer, are there other kind of things that your sensors can, it's actually, I'm guessing yours isn't a hardware platform, obviously, it's a software platform. So I'm guessing you can take in data from any kind of sensor and then work with that, correct?
That's correct. You're right. Because I'm not an expert in making sensors, but luckily there's a lot of great manufacturers out there that built hundreds of different sensors to measure all kinds of aspects of the environment.
So you don't care about the sensors, you don't care about the comms infrastructure, it's all just sucking in that data and then working with that.
Yes, I do care a little.
Okay.
you want the stuff to work,
Right.
I did spend a lot of time at Ericsson hearing about comms and what's interesting when I talked about being prescriptive about these use cases, I try to cover everything. So I was like, for this use case, whether it's water or whatever, it's like, I want to say it's this device, it's these sensors specifically, it's this kind of electricity, and what kind of battery am I using, solar, whatever I'm doing there, can I connect to main power, whatever. And I do talk about connectivity. what's the right kind of connectivity to be using? What kind of wireless or wired connectivity? Am I using LoRa or cellular or satellite or Ethernet or whatever? Because I don't want people scratching their heads saying, "Oh, you skipped this part. I don't know what to do." And so we do care about that. And also, there's a cost, right? And I've noticed lots of, like, back to farming, I noticed a lot of farmers have been deploying LoRa just because the cost is low. We can never forget that in spite of our best intentions to do good, economics has a way of kind of trumping any of our best ideas. If it's not economically viable, people aren't going to do it. If I have a cellular data plan that's costing me money versus if the amount of data I'm sending, it can go kind of for free over LoRa, well, maybe that's the best choice. Just like you should be using a microcontroller out in the field versus a Raspberry Pi or something like that, right? Because it's just barely sipping energy. But yeah, all those things are important. And so I do talk about that. And I say, should you be using an edge platform or should it be running in the cloud? And then what is the simple analytics algorithm? What's the simple thing you need to do to drive the outcome you're looking for? You and I've seen so many science experiments with all this technology over the years. People forgot that they're supposed to start with the problem first and the outcome they're looking for and work backwards to decide what technology is appropriate. But I think people got mixed up on that somewhere along the way, didn't they?
They did, yeah. That happens all too often. Oh, there's some new shiny technology. Now I got to find a problem.
Yeah, absolutely. Absolutely. You're so right. Oh, boy. Yeah, it's crazy stuff.
Has this been deployed anywhere yet, Rob?
Yes, it has been deployed in some farms in eastern Washington, apple orchards and hops farms. We're coming for you, Germany. A lot of people don't know. All right, so obviously a lot of people think of hops, they think of beer, as well they should. What they don't realize is there's these two areas that are neck and neck for leading the world in production of hops to make beer. Normally we think of Bavaria, but the other place that's kind of right there tied for number one is this town called Yakima, Washington, in eastern Washington, produces just as much as Bavaria does. And
no way.
Yeah, and it kind of dominates a lot of the beer production all around the world.
Wow.
Especially if you go to craft beer. Yeah. See, we learn something every day, don't we?
There you go. It's school day.
Absolutely. Yeah. Another thing about resources or something that's easy to do, because it's important that all this the platform has to be simple to use. Deploying the technology needs to be simple. It needs to be Forrest Gump simple, actually, is kind of where my head's at. And so, I found myself presenting at an oil and gas conference. Who knew? In Houston, Texas, which is the oil capital of the planet. That's where they're all headquartered there. And I did a presentation on getting the entire oil and gas industry to net zero. And so I thought they were going to boo me out of there. Maybe, who knows? I'd say in the last couple of years, I think a lot of the super major oil companies are kind of taking it seriously a little bit, and so I hear them talking. Now, you and I know it could be real or it could be virtue signaling to just look good, right? And lots of people do greenwashing. And when I build this technology in this book, this is me helping be on a mission to help people stop greenwashing and using ridiculous things like carbon credits to pretend that they care about the earth, right?
Yeah.
And so it's like, let's make it real. And so one of the things you can do, so in the oil and gas industry, there's upstream, which is where they do drilling, exploration. So whether it's out in West Texas or in the Gulf of Mexico or the North Sea or Saudi Arabia. There's midstream, which is storage. You see those big storage terminal tanks and everything. You see transportation, oil being transported in trucks, trains, super tankers, which is also kind of silly when you think about it. Those super tanker ships use so much diesel just to power themselves to go across to the other side of the planet, just to move oil to somewhere else. Yes, I it's not lost on me, the irony behind all that. And so there's that transportation part that's midstream, and then downstream is the refining part. You refine, crude oil, into different petrochemicals, all kinds of things, which is actually something for people to remember. Just even if we cut back production of using petrol, gasoline in your car or diesel, so many products all around you that you don't realize are actually all petroleum products. Actually, like a lot of them. It's pretty interesting. There's a lot of work to do just beyond getting people to use electric or hydrogen cars, right? No doubt about it. Anyway, what's one thing you can do though to help in all those areas, that upstream, midstream, and downstream? Just start doing continuous monitoring. So I'll give you an example. Every country has something, an environmental protection agency, kind of like, in the US, we have the EPA, and there's all these other things. And they might say, hey, I need you to go out to this tank farm in the middle of nowhere twice a year and do a reading on CO2 and methane emissions. And methane's much, much worse than CO2, but it doesn't get the headlines. And just do a reading and take a sample and then write it and report. And we need you to do that twice a year. So, our good friend gets in his pickup truck and drives out to the middle of nowhere in West Texas or Oklahoma and does a reading and says, yeah, we're good. I wrote it down on my clipboard and we're going to get that submitted. Then he drives his pickup truck back home. What if when he was driving away, a methane leak started by accident right then, and he's not going to come back for 6 months? This is a real thing. And this is actually human nature. We do things on a periodic motion that says, change your oil in the car after this many kilometers or miles. Well, today, though, we have this technology that lets us do it continuous monitoring. And so instead of driving away and having it leaking for 6 months before they come back to check again and realize, wow, it's too late now, I've just destroyed the planet, sorry. Instead, with not a lot of money, simple sensors that can monitor these gases and the magic of all these wireless networks we built and a simple platform, you don't need a platform that can handle millions of messages per second. Actually, something pretty low end can handle it. Let's do that. Let's do continuous monitoring everywhere, all over the place, all these places where there's possible emissions, so that we can find out about it quickly and go take care of the problem right away before it gets out of control. There's so many little things we can do in all kinds of industries. And so you can imagine doing that continuous monitoring in all these locations for all types of things. I think it's just, you need to have the will and the plan to do it. And so I know we've thrown a lot of technology out there, but I know a lot of people still don't have a plan or a roadmap or a guidebook. And so that's kind of why I'm writing this book, because I want to put something in their hands that says, I know you don't know what to do, and I'm going to show you what to do. Here, go do this. And you're going to look at it and you're going to go, oh, this isn't hard. I can do this. And it's not going to cost that much money. So, okay, I wish I'd known this before, that kind of thing.
And is the book prescriptive for the platform, or are they independent?
It's independent. You can use the platform, and I'll make references to the platform, but it's generic. I don't want to play favorites in the book. I don't want the book to be an advertisement for some technology. The book it's super generic. I'll describe the analytics, which is usually pretty stupid, simple, and describe, anything that can ingest data. It's no big deal. It's funny when we talk about IoT and what platform, I know we've had discussions with all the companies who have been shutting down their big hyperscale IoT platform the last year.
Mm-hmm.
A lot of them have. The funny thing people don't know is typically the number one competitor to all these big IoT platforms isn't another platform. It turns out it's bespoke stuff built internally by IT departments. Whenever you talk to an engineer and they say, well, should we buy this? Oh, wait, I could write this code in a weekend. Turns out that's the biggest competitor, ironically. So like when I was doing Greenhouse, I was thinking, what's the opposite of a hyperscale IoT platform like Azure IoT or Leonardo? I remember I used to work with Leonardo at SAP. I spent a lot of time in Waldorf when I was with Hitachi Lumada. We were trying to do some stuff where our digital twin technologies could interoperate with each other, that was a lot of fun. But I was in my mind, I was saying, one, what is the WordPress for IoT? What is something that I could just use a hoster, like a low end web host companies that predate the cloud that are inexpensive? What's something that could do that? So that was in my mind too. And actually in this greenhouse thing, I could run it on a $7 a month hoster, and it could probably handle a whole lot of probably every farm in a whole state or a province, believe it or not. So
well,
it's interesting. It's amazing what you can do when you put your mind to it and you realize, I think we're over-engineering a lot of technologies out there, building for something that never came. We built for, again, systems that were expecting tens of millions of messages per second. And it turns out the reality in IoT is probably throughout the last 10 years, we probably had fewer transactions, messages on all IoT systems than one day on the New York Stock Exchange. So go figure.
That's fair. Yeah.
Yeah.
And where to next, Rob, for Greenhouse, for the book, for yourself? What's coming down the line?
Yes. So right now I've got lots of friendly folks helping test Greenhouse to find bugs, make sure it's usable. And so, for this kind of 1.0 release, and so probably do some refinement there based on user feedback. But that'll be out the door, and people can just download it and use it. And there's a 26-page tutorial that shows you how to use it. And then the book should be out in the next month. And so we'll get that out to folks, through all the usual channels, right? And they just kind of work hand in hand. So yeah, looking forward to having all that stuff out the door and get it in people's hands so they can use it.
All right. Okay. Well, when the book does come out, shoot me the link and I'll update the show notes for this episode with the link.
Absolutely. Will do.
Okay. Well,
for sure.
We're coming towards the end of the podcast now, Rob. Is there any question that I haven't asked that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
I don't know. I wish I was so much more prepared for more aspects. I would just say, don't overthink things. You know what? In your own life, go online and take a look at those 17 sustainable development goals and find ones that, that look familiar to you in your own life and your day to day, and stuff where you can make a difference. Because a lot of times people don't know where to start. They don't know how to categorize things. And so they might find out, it turns out hunger and poverty are both aligned to agriculture. The most extremely poor people in the world all work in agriculture, as it turns out. And of course, hunger is directly related to agriculture. To bring it home for you, Tom, Mr. Supply Chain, there's another scary thing about food. Let's say we knock it out of the park and do a great job on the farm with all this technology to improve crop yields and things like that. What is one thing, though, that is really sad about what happens after harvest? Apparently, we are losing more than 30% of the food is lost or wasted in the supply chain after harvest. So after it leaves the farm, goes into, some things go into cold storage, there's processing plants, and then they go into big giant 18-wheeler trucks with distributors, and they start making their way through this part of the supply chain. And you've heard, one of the oldest IoT things was cold chain, right?
Yeah.
And so the fact that we could do a great job on the farm and still lose 30 or 40% of the food is heartbreaking. And so we need to be using the same technology to ensure that the rest of the supply chain, from that farm to the grocery store, to the restaurant, to your table, that we secure that too. Because if we can make a dent in that 30%, that's all good for humanity. So lots of work to do in the supply chain for sure.
Nice. Rob, if people would like to know more about yourself or Greenhouse or any of the things we discussed in the podcast today, where would you have me direct them?
I probably spend too much time on LinkedIn. Yeah, they can find me on LinkedIn, Twitter at Rob Tiffany. I've got a blog, robtiffany.com. And so, yeah, I do lots of writing and publish lots of stuff on all these different channels. And then, of course, I talk with a bunch of crazy people on IoT Coffee Talk every week. And that those are all videos and podcasts that go out. So you can hopefully find a hidden gem buried in all the silliness.
Okay, great, great. Rob, that's been really interesting. Thanks a million for coming on the podcast today.
Actually, my pleasure. Thanks so much for having me.